In this video, we're going to look at topic 18, example 2, graph a system of equations with infinitely many solutions or no solution. What is the solution of each system of equations? Use a graph to explain your answer. So we'll look at part A, and I have 15x plus 5y equals 25, and y equals 5 minus 3x. So I'm actually going to look at the second equation first and plot that. So I know that my slope is negative 3 over 1, and I know I have a y-intercept of 5, so I can plot that. So I'd plot the point 5, and then I would go down 3 and over 1, and I would keep doing that to get a couple of points, and then I would connect those points. So we have something, that was pretty inaccurate, but fortunately for technology, we can fix that. So that'll be my first equation. Pretty easy to graph that one, right? We're given the slope, we're given the y-intercept. So good start. Now, the second equation, the 15x plus 5y equals 25, I would use, in this case, this is in standard form, so I would try to find the x and the y-intercepts. To do that, and I don't have a ton of space here, but remember that we set the other one equal to 0, so if we're looking for the y-intercept, we would set x equal to 0. So in this case, if the 15x was a 0 and that canceled out, then 5 would be equal to y. So I have a y-intercept of 5. Now again, I'm kind of taking some liberties here and some shortcuts, but if you solve for the intercept, the y-intercept, you would get 5. So I'd plot that point right here. And then my x-intercept, I'll show a little bit more work here though. This would be 15x equals 25. We would divide both sides by 15. So that would be 5/3. And what's going to happen is that's 1 2/3, which if we were to graph that, is going to be, oh, that is definitely the wrong marker, is going to be right here. All right, so this would be, we'll say 5/3 or 1 1/3, but that's the x-intercept. The main idea here is those 2 points are on the same line. So if I connect these dots, what's going to happen is I have the exact same line, which tells me that these two equations are really the same equation, just in different forms. So the first one is in standard form. If I was to convert that to slope-intercept, I would wind up with that second equation. Maybe I'd have negative 3x plus 5, but it'd be the same thing. So in this case, these two equations overlap. They intersect at every single point, right? They share every single point, exactly the same. So what happens here is that we have infinitely many solutions. Because ultimately, these are the same line, just in two different forms, or the same equation in two different forms. So for this specific example, if they overlap into the same exact line, they have infinitely many solutions. If I was to graph that, we'd kind of get that same idea. I'm not going to type it in over here, but you would see that. So equation, or part B, in part B, let's actually get rid of this. In part B, we have y minus 2x equals 6. So I'm going to rewrite that. I'm going to move the 2x over. So I get y equals 2x plus 6, which means I have a slope of 2 over 1, and I have a y-intercept of 6. So I'm going to plot that. So plot the y-intercept. My slope tells me to go up 2, right 1. So I'm going to do the opposite of that, down 2, left 1. Mostly because here, we don't want to go off the graph, right? So I'm just going to plot a whole series of points, and then connect these dots. So I have my graph. Now the second equation, we have it in standard form, so we need to find some intercepts. So that means for the x-intercept, I can set y equal to 0. So again, I apologize that I'm kind of squeezing all this in here. So I have negative 4x equals 8, which means x would be negative 2. So I'm going to plot that point here. That would be my x-intercept. And then my y-intercept would be 2y equals 8. And I would divide by 2, so y would be equal to 4. And I'll plot that right there. And then I would connect these dots. Make that a little more accurate. And we'd have that. Now, the problem we run into here is these two lines don't intersect on our graph. Now, maybe they do eventually off the graph, but in this specific case, if I take the second equation, the negative 4x plus 2y equals 8, if I was to solve for y, if I add 4x and I get 2y equals 4x plus 8, and then I divide everything by 2, I get y equals 2x plus 4. And what we need to notice here is that my slope is the same in these two problems, or sorry, in these two equations. And if the slope is the same and they have different y-intercepts, these two lines are parallel. If they're parallel, they're never going to intersect. And we can't have a solution to a system of equations without the lines intersecting. So since these two lines never intersect, there would be no solution. Again, we would say it's because the lines are parallel. Having the same slope and different y-intercepts means that they're parallel, and if they're parallel, they won't intersect. If they won't intersect, we don't have a solution.